All right, let's just jump right into it. We hear all the time about AI getting smarter, right? But what if an AI could do something more than just, answer questions we already know the answers to? What if it could actually make a totally new discovery?
I mean, that's kind of the ultimate question for AI research, isn't it? It's the North Star for the whole field. Can an AI really push past the edge of what we humans know and find something completely new? Well, you know what? It looks like we might finally be getting our first little glimpse of an answer.
And that's because, according to a brand new paper, one of the latest, most advanced AI models out there, the researchers are calling it GPT 5.4 Pro for this study. It might have just made, get this, not one, but two potentially brand new contributions to unsolved math problems.
So how in the world did this happen? Well, to really get what a big deal this is, we've got to look at how we're even measuring AI when it's operating at the absolute frontier of science.
And this is really the key here. We're not talking about solving some homework problem where you can just flip to the back of the book for the answer. No. We are talking about tackling problems that have had mathematicians totally stumped for years. And the AI found solutions that are actually better than anything we had before.
But to really appreciate why this is so huge, first we have to talk about why our old ways of testing AI just aren't cutting it anymore. There's a big fundamental problem with how we've been grading these things.
You see, the standard tests, things like math or GSM-8K, they're getting way too easy. The researchers call it saturated. The top models, they're acing them, scoring over 90%. And look, when everyone in the class gets an A+, the test doesn't really tell you who the real geniuses are anymore, right? It just can't measure progress when you're at the very edge of what's possible.
So here's the crucial distinction we've got to make. Most tests are all about problem solving. Think of it just like a final exam in school. You're being tested on stuff where the answer is already known. But discovery, that's a whole different ballgame. That's the research frontier. That's trying to find answers that literally nobody has yet. And that is a much, much harder thing to test.
Okay, so that's the problem. And this is where a totally new approach comes into play. It's a new benchmark, one that's built not for the classroom, but for the research lab. A test designed from the ground up to measure actual discovery.
It's called Horizon Math, and what it is a collection of over 100 genuinely unsolved math problems. And here's the clever part. Because the solutions are completely unknown, there's no way they could be in the AI's training data. This makes the test completely immune to what we call data contamination. Basically, it's cheat-proof. Any correct answer has to come from genuine insight.
And this thing is incredibly comprehensive. We're talking 101 problems spread across 8 different domains of math. Everything from number theory and discrete geometry all the way to continuum physics. So yeah, this is not some little niche test. It's a really broad exam of an AI's ability to reason across all these different, really advanced fields.
The whole system, this Horizon Math, is built on 3 main pillars. First, you've got that set of unsolved, cheat-proof problems. Second, there's a fully automated way to check the answers, so you don't even need a human expert. And third, the whole thing is open source, which means anyone can use it, check it out, and even contribute to it.
Okay, but wait a second. This brings up a pretty fascinating paradox, right? If nobody knows the answers to these problems, then how on earth do you grade the test?
Well, the solution is in this really cool concept called the generator-verifier gap. Just think about a Sudoku puzzle. Actually solving it is super hard. It takes real thinking. But once you have a finished grid, checking if it's correct, that's trivial. You just check the rows, columns, and boxes. Horizon Math is built entirely on problems that have that same property.
So here's a quick rundown of how the automated pipeline works. The AI doesn't just write down an answer, it submits it as a piece of code. A special checker then immediately scans it and filters out any attempts to cheat or use weird shortcuts. After that, the valid code gets run and checked against the rules of the problem. And the final result? It's a simple, totally objective pass or fail. No human grader needed.
So it all starts with the AI generating an answer. The model gets the problem and basically a template for a Python function. Its job is to fill in the blanks with the actual math, a symbolic expression, or some kind of construction. It has to be a concrete, verifiable answer.
All right, so once that code is generated, it hits this really important gatekeeper called the admissibility checker. This is the first line of defense. It throws out any weird numerical hacks or anything that breaks the rules. If the solution looks legit, then it gets passed along to one of 3 automated verifiers that does the final check to see if it's a valid new discovery. Okay, so the stage is set. We have this brand new, incredibly difficult test designed to measure real, actual mathematical discovery.
So what happened when the best AI models in the world took a crack at it?
Well, the results were staggering, and they really confirmed just how brutally difficult this thing is. Across all 101 unsolved problems, even the world's most advanced AIs just slammed right into a wall. Most of them scored at or near zero. And honestly, that proves Horizon Math is working exactly as it's supposed to. This isn't a test you can just ace. It's a tool designed to find that absolute razor-thin edge of what AI can do.
So if you look at the overall scores, you'll see Claude Opus and Gemini Pro solved about 3% of the problems, while GPT 5.4 Pro got up to 7%. But, and this is a really critical detail, a lot of those successes were on easier calibration problems. The researchers put those in just to make sure the test was working right. On the truly unsolved problems, well, that's where something else happened.
Because despite that overwhelming difficulty, 2 of the answers that GPT 5.4 Pro came up with, they weren't just correct, they were new.
The AI came up with 2 solutions and they're still waiting for final expert review, of course, but they actually seem to improve on the best results humans have ever found. For one geometry problem, the thin triangle Kukea problem, it found a construction that's over 8% better than the old record. And for another really complex one called diagonal Ramsey numbers, it found a new set of coefficients that actually tightened a long-standing mathematical bound. So basically, it helped us narrow down the possible answers for a very, very hard question. These aren't just right answers. These are genuine steps forward for human knowledge.
And all of this leaves us with a pretty profound question, doesn't it? I mean, we are just at the very, very beginning of this journey. But if AI is already starting to contribute to the absolute frontier of human knowledge, if it's helping us chip away at problems we thought were completely unsolvable, you just have to wonder, what discoveries are waiting for us just over the horizon?